Alright, here's another video continuing talking about all the simple machines. And yesterday when I tried to do the first three, I think it took too long. So I'm just going to do incline plane tonight. It's not like everybody's about done with the activity, so I don't necessarily need to rush. So just the incline plane, and hopefully that's only about a 5, 6, 7 minute video at most, and then that's no big deal. Okay, so first thing to note is AMA really is the same thing for all simple machines. So when you find AMA, what you're always doing is you always take the force that you're overcoming, which is, for FR over FE. That is always your AMA, regardless of the thing, the simple machine or a compound machine. All right, it's always FR over FA, period. All right, now the IMA varies from, or the formula, the way you figure out IMA, the ideal mechanical advantage, varies from machine to machine. So yeah, how much effort you can overcome divided by how much effort you actually put in. Now on the incline plane here, IMA, it's actually relatively easy if you just have the numbers. There's nothing tricky to figure out. What it is the IMA, well, it's always DE over DR. However, how you figure out DE, DR depends on the machine. And so in this case, the effort distance is how far you're actually traveling. So guess what? You're going up an incline plane, you're going up some kind of ramp. That's this. This is DE, this diagonal distance on the incline plane. So whatever that length is, that's your DE. DR is how much you have to overcome, how much, alright, that's the distance that what's being overcome travels. That's just straight up and down. The whole point of an incline plane is that you don't have to jump up from here to here. Oops. From the bottom to the top. Okay, you can go diagonally. You just take a lot longer, but it's a much easier thing to do. And so this, the vertical distance, is DR. So DR is that, and then DE is the diagonal distance. So straight up and down, straight up and down is the resistance distance, and there you go. Thank you for the color coordinate. The DE, so the DE is on top, so it's the diagonal divided by the vertical distance. And so there's actually, even though it's just a triangle, an incline plane, so it's a lot less complicated seemingly than, well, the wedge is pretty straightforward, but the screw seems much more complicated, so we'll talk about soon here. It's actually got a little bit of this and that to figure out what DE and DR are sometimes. And really the two things that might come into play, and when I say that, they definitely will come into play in the activity problem for incline plane, is the Pythagorean theorem, okay, and slope. Slope is rise over run. So the Pythagorean theorem says that when you have a right triangle, and I know that doesn't look, I didn't specify this right triangle, but it is. It's supposed to be. That's part of the premise. The sides, if you label them as A, B, and C, the Pythagorean theorem holds up. That formula, this side squared plus this side squared equals the longest side squared. Longest side is called the hypotenuse. So hopefully you guys have seen this formula. If not, I'm going to show you it in use once here. The slope is rise over run, and rise, the slope of this line, now it's oriented in a funny way, but because you're used to, just remember, everything's positive. So you might think, oh, the run should be negative because we're going to the left. Well, no, we're not. Don't worry about it. Run is how far to the left and right you're going. Rise is how far up and down you're going. Okay, so rise over run is the slope. So let's walk through an example, and then that'll be that. Okay. So say you have a ramp is 1 to 10. If the height is 4 feet, what is the mechanical advantage of the ramp? And that is a question, and I didn't. How embarrassing. Right? So first thing is, actually I can bring down, let me bring this sucker down. Copy, paste. Start labeling stuff. So the height is 4 feet. So I know we got 4 feet here straight up and down. Okay. Okay. The slope of the ramp is 1/10. So this, I wrote this like this. This means the slope is 1/10. Sometimes you see that as a ratio. So that means that rise over run is 1/10. Okay? So using the numbers from up here, run is A, so I'll put that down here. And so our rise over run is 4 over A. So 1/10, the slope is rise over run, it's a 1/10, but it's also 4 over A. So I can make an equation. Rise over run is 4 over A, but it's also 1/10, and then this is a problem we can solve for A. Okay, so we cross multiply is a phrase I kind of hate because students try to do cross multiplication when you're not supposed to, but here you're supposed to. Cross multiplying is right here. A times 1 equals 4 times 10, so it's 40. So A is 40 feet. Okay, and I know it doesn't look like it, but if I had made it to scale right, it would have been all the way across the stupid screen, so it would have been silly. Alright, so A is 40 feet. But what's up is, no, I just kind of jumped into it. The reason why we have to find A is we want DE over DR. Well, DR is right here, it's 4. DE, we don't know. So DR is 4. DE is, well, I usually use lowercase, so E for effort. So you're traveling diagonally up the ramp, so that's the effort distance. Hopefully that makes sense. That's how long you're putting the effort in. E. Alright, so DR over DE is the ideal mechanical advantage. And I said it backwards, oh my goodness. DE over DR. It's easy to get them switched because it is switched for forces. DE over DR. So, oh shoot, we don't know what DE is. Okay? Well, once we figured out A, and let me write it in here, we can use the Pythagorean theorem to figure out what DE is. So this is A, this is the B, and this is the C. So we want to find DE. We do, in fact, let me pull the equation down. Okay, so it's 40 squared plus 4 squared equals DE squared. Nice. Okay. So this works out to be 1,616 is DE squared, the effort distance squared. So how do you solve something that looks like this? You might, hopefully you've seen this before. If you want to solve something, blah squared equals a number, then what you do is your thing you're trying to find out, in this case DE squared, is just equal to the square root of the 16. And that is 40.2 apparently. Don't forget, you need a scientific calculator for this class. At least. The graphing calculator is cool too. But you definitely need a scientific calculator. And yeah, it's 40.2 feet. Okay? So finally, we use slope, use Pythagorean theorem. Finally, we can go formula dE over dr. So dE is the 40.2, dr is the 4. So AMA, when you're doing distances, it's AMA. Whoa, no, I'm totally, alright, I'll just pretend that didn't happen. It is the ideal mechanical advantage. What am I saying? I was right the first time. Ideal mechanical advantage involves distances. Actual involves the actual forces that for real happen. This is just kind of theoretically. So it's dE, so it's the distance traveled, so it's 40.2 feet over 4 feet is the actual vertical distance you're overcoming. And that's approximately equal to 10.05. There are never units for IMA. I could have put feet and feet here, but look, I mean, I don't know if in science classes you've talked about it like this. Feet just cancel. So that is why that should always happen for any sort of mechanical advantage calculation. So you never ever need units for IMA or AMA for that matter. Mechanical advantage is unitless, which might seem a little weird, but that's the deal. So tomorrow I'll probably put up the last two because those are each shorter than this, so it should be fine. But there you go. Hopefully that's helpful with the inclined plane problems.